In this video, I'll be talking about relative velocity. Relative velocity is the velocity of one object with respect to another object. I'll just write down here. So it is object. So let's assume we have a car. Let's say we have a car here, and this car is moving with 75 mile per hour with respect to an observer which is sitting or standing here. And now let's say you have another car which is also moving with 75 mile per hour in the same direction, both moving in the same direction. We call this object or this car A, and we call this as a car B, and this is an observer, so just write down O. O stands for the observer. Then the velocity of car A, so VAB, the VAB, that means the velocity of car A with respect to car B. Car B. So what is the velocity of this car with respect to this car? As both are moving with exactly the same speed in the same direction, the relative velocity is equal to the 0. And now if I take the velocity of car with respect to observer, that means the velocity of this car with respect to this observer, then this, I will just write it down here. This means the velocity of car A relative to observer O. And we know that this is 75 mile per hour. Similarly, the velocity of car A, velocity of car B with respect to observer O is again 75 mile per hour. Now let's assume this car is moving in the other direction. If you have a car which is moving in the opposite direction, let's say it's hard to, okay, let's say this car is now if we're moving in the opposite direction, then the distance between A and B would be changing with respect to time. There would be more separation between the two cars if this car were moving in the opposite direction. If car B were moving in opposite direction, then the velocity of car A with respect to B would be simply equal to 75 minus 75. This 75 is the 75 mile per hour of this object, or I can write it down this way in a better way. or you can write down the velocity of B minus velocity of A, or this can the most appropriate way of writing this one A is the velocity of car A with respect to observer O minus velocity of car B with respect to observer O. This one we say is 75. If we take this direction as a positive direction, minus, as this car, if this car were moving in the opposite direction, then it would be negative 75. So it would be 150 mile per hour. So if the two cars were moving in the opposite direction, then the relative velocity of one car with respect to another car would be 150 mile per hour. Now, how do you, let me give you a little bit more mathematic background here. So, let's say you have two cars here. This is the car, this is the position. So let's say this is car A and this is car B. These, and this is the x coordinate and this is the y coordinate and this is the origin, and we call the position of the car A with respect to this origin, which is denoted by RA0, that we call the position vector. The same way, the position of this car B with respect to this observer or this reference point, we call it as the position vector of car B, and it is denoted by this. And here you have an arrow. The arrow denotes the vector and direction too. And here our goal is to find out the position, or how does the position of car A is changing with respect to the car B. This is RAB vector, or we simply call, how do you write down RAB again? If you have to write down RAB, the way you just write down is first write down RA minus RB and then write down O and O. That's how you write down here. Okay, and it makes sense. RAB, if you need to write down RAB, then you have to go this way and then this way. So RBO is negative, which makes sense. So RAB, let's say you have a vector here, RAB vector, this arrow. If you need to go from B to A, the path is going this way, so it will be negative, and then this way, which is positive. So we have RAO minus RBO. So RAO vector is the position of car A with respect to observer O. Similarly, RBO is the position of car B with respect to observer O. Now our goal is to find out RAB. What is the RAB means? What is the position of car A with respect to car B? This gives you the position car B. So now I'm calculating RAB vector. Again, as I said, if you want to write down this vector, how do you write down? First start with RA vector minus RB vector in the same order. And then now you want to find out with respect to, because this position RA is given with respect to observer O, so you just write down O here and O here. Alright, then this becomes RAB vector. This is the position vector of car A with respect to B. Now I'm taking the time derivative. The time derivative this is RAO vector minus d over dt RBO vector. This means this is the position of car A with respect to B. So this will give you the velocity of car A with respect to car B. And this is the velocity of car A with respect to observer. And this gives you the velocity of car B with respect to observer B. So what you see here, if you need to find out the velocity of car A with respect to car B, then you need to, then it's simply equal to the velocity of car A with respect to an observer, and then a negative or the minus the velocity of car B with respect to the same observer. That's how you find out the relative velocity. So this is the formula for calculating the relative velocity of one object with respect to another object. You see, this comes out simply the difference of the velocity with respect to a fixed observer. All right, thank you.